In this video, I'm going to talk about image formation by plane mirrors. So that's a mirror. One side is polished. Consider an object. For simplicity, we're going to use a point object, but you can apply it to like any shapes. Yeah. So that's our object. I'm going to draw a ray that's coming from the object and hitting the surface of the mirror. Draw a normal at this point. So this is the incident ray. By law of reflection, this incident ray should be reflected back at the same angle by this mirror. The angle of reflection should be the same. Theta r should be equal to theta I. You can either measure the incident angle, and draw the reflected ray at the same angle, or just count the squares. So this point is 1, 2, 3, 4 squares down. Now the reflected ray should be 4 squares down as well. 1, 2, 3, 4. Okay. Yeah. That's my reflected ray. Yeah. I'm going to delete all these numbers. Now we need one more incident ray and reflected ray. Second incident ray at this point. That's like 1, 2, 3, 4, 5, 6 squares down. Draw the normal. Yeah, the reflected ray should be 6 squares down as well. So 1, 2, 3, 4, 5, 6 here. So let's draw the reflected ray, the second reflected ray. I'm going to delete all these numbers. Now we have two reflected rays. These rays are coming to our eyes. So we are looking at the mirror from here. These two reflected rays are coming to our eyes, but our brain thinks these rays were traveling in a straight line, so it creates an image at the back of the mirror. Extending the second ray as well. An image is formed at the point of intersection of these two rays. So that's the image. What you actually see is an image behind the mirror. It's not real. So we call it a virtual image. Okay, now let's count the number of squares from the object to the mirror. That's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 squares. Count the number of squares from virtual image to the mirror. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 squares. That means the distance from the object to the mirror is equal to the distance from the image to the mirror for a plane mirror. Let's call this distance XO, object distance, the distance from the object to the mirror. Let's call this distance XI, image distance, distance from the mirror to the image. Let's write an equation. They're equal. So XI is equal to XO. I'm going to draw a coordinate system with the mirror at the origin. So that's the y-axis. That's the x-axis. X, Y. Both image distance and object distance are on the x-axis. Xi on positive x-axis. Xi is on positive x-axis, and XO is on negative x-axis. xi, which is the image distance, is measured from the mirror to the image, and that is positive. So xi is positive. Whereas the object distance is measured from the mirror to the object, that's going to the left. So it's negative. XO is negative. So we need to put a negative sign. And that's the equation connecting image distance and object distance for a plane mirror. Xi is equal to minus XO. Height of the object should be same as height of the image as well. Now, if you replace the point object with something with a non-zero value for height, draw two rays from the bottom as well, and do the same thing. They will converge somewhere here, forming an image with the same size. Okay, yeah, that's the image. So they will have the same height as well. We can write the equation as height of the image is equal to height of the object.